Welcome back. Part 3 of AI Agent Loop Patterns. In Part 1, we wired up the basics. Think to act, to observe, then layered conversation, live narration, and parallel tools when calls don't depend on each other. In Part 2, we stayed closer to production pain, iterate on purpose, reflect before you blindly retry, persist what matters, and guardrail it, and plan before you thrash tools. This episode stacks the last pieces on top of that foundation. First, chain of thought plus ReAct, deeper think steps for hard math, tool choice, or brittle logic, and why shipping raw chain of thought is often a bad idea for privacy and UX. Then tree of thought plus ReAct, when one line of reasoning isn't enough. Branch, score branches, prune, then commit to an act only after you've compared plausible causes. Next, sandbox execution. Prove behavior in a throwaway environment before a diff ever touches prod. Clone, test, replay failures, open a PR, let CI gate it. Finally, react with learning. Close the loop on real feedback. Store strategies before you fantasize about fine-tunes or RL, because bad rewards teach bad habits unless eval and rollback exist. We land with a blunt wrap-up. You don't collect patterns like achievements. You negotiate trade-offs and pick the smallest loop that ships. Part 1 and Part 2 are linked in the description if you need the run-up. You can still follow Part 3 if you're solid on plain ReAct. If this helped, like and subscribe. It pushes the lessons to people who actually care about the topic, and you'll catch the next videos in this series. It costs you nothing, but it means a lot to me and my team. If something clicked or you have a question, leave a comment with your use case. I read comments, and they steer what I publish next. To learn more about me, visit this page. For agents, RAG, MCP, and related pages, visit this page. Same links are below in the description and pinned comment. Huge thanks. Your attention makes the work worth it for me and everyone behind the channel. Chain of thought plus ReAct means the agent uses more explicit reasoning during the think step. The loop is still think, to act, to observe, to repeat, if necessary, to final result. But the thinking is more detailed. This can help with difficult reasoning, math, planning, or tool selection. The model breaks the problem down before deciding what action to take. The benefit is better accuracy on complex tasks. The cost is verbosity, latency, and privacy concerns. In many production systems, you do not want to expose or store raw chain of thought. Instead, you may show a short summary of reasoning while keeping internal reasoning hidden. So the practical idea is, use stronger reasoning when the task is hard, but do not expose every internal thought to the user. Example: a store gives 20% discount on a $50 item, then adds 10% tax. What is the final price? Think, detailed reasoning. Original price equals $50. Discount equals 20% implies $10 off price after discount equals $40. Tax equals 10% of $40 equals $4. Final price equals $44. Act. Perform calculation step by step. Observe. Computed final price is $44. Final result. The final price after discount and tax is $44. Tree of thought plus ReAct is useful when one reasoning path is not enough. Instead of thinking in one straight line, the agent explores multiple possible paths. The loop is more like generate options, arrow, evaluate options, arrow, choose path, arrow, act, arrow, observe, arrow, repeat, if necessary, arrow, final result. For example, if an agent is debugging a production issue, there may be several possible causes: database problem, API problem, deployment problem, cache problem, or bad input. A normal ReAct agent may follow one path. A tree of thought agent can compare several paths before acting. This helps with complex reasoning because the agent does not commit too early. The trade-off is cost. Exploring multiple branches takes more tokens, more time, and sometimes more tools. It can also become messy if the system does not prune bad branches. So this pattern is best for hard problems where the first idea is often wrong. Debugging, planning, architecture decisions, research, and multi-step reasoning. Use it when quality matters more than speed. Example: my production API is slow and sometimes times out. Find the cause. Generate options. Branch A, database bottleneck. Branch B, API server overload. Branch C, cache misconfiguration. Branch D, external service latency. Evaluate options. Branch A, act, check DB query performance. Observe, some queries are slow, but not all requests affected. Branch B, act, check server, CPU, and memory. Observe, CPU spikes during traffic peaks. Branch C, act, inspect Redis cache, hit rate. Observe, cache hit rate is very low due to misconfigured TTL. Choose path. Cache misconfiguration is most likely root cause. Act, fix Redis, TTL configuration, and warm cache. Observe, API latency significantly improves, timeouts disappear. Final result, issue was caused by cache misconfiguration, leading to excessive database load. A sandbox execution agent is an agent that tests actions in a safe environment before touching the real system. The loop is: think to act in sandbox to observe, result to fix or approve, then apply safely, then repeat if necessary, then final result. This is common in coding agents. Instead of directly changing production code or running dangerous commands, the agent works inside a controlled environment, a test project, isolated branch, temporary file system, container, or restricted runtime. For example, the agent can write code, run tests, inspect errors, and retry inside the sandbox. Only when the result looks correct should it move toward the real target. The benefit is safety. The agent can make mistakes without damaging production data or user files. The downside is setup complexity. You need a reliable sandbox, good permissions, test data, and clear rules for what the agent is allowed to do. Use this pattern when actions can have side effects: code changes, database writes, deployments, file operations, or automation that touches real systems. Example: fix the bug in my payment API without breaking production. Think: I should not modify production directly. I will use Sandbox. Act, Sandbox. Clone repo into isolated environment and run tests. Observe, tests fail on payment validation module. Think: I need to reproduce and fix the issue safely. Act, Sandbox. Update validation logic and rerun tests. Observe, all tests pass in Sandbox environment. Think: changes look safe. I can now apply to production branch. Act, create patch and open PR with validated fix. Observe, CI pipeline runs successfully, no errors. Final result, payment API bug fixed safely using Sandbox validation before production deployment. The final pattern is react with learning. Here, the agent improves from experience. The loop becomes think to act, to observe to feedback, or reward to repeat if necessary. To final result, learning can happen in different ways. The simplest version is storing corrected strategies. For example, if the agent failed and the user corrected it, the system stores that correction and retrieves it later. A stronger version is fine-tuning, where feedback data updates the model. An even stronger version is reinforcement learning, where the agent improves from rewards and outcomes. The benefit is clear. The system gets better over time. The risk is also clear. It can learn the wrong thing. Bad feedback, noisy data, or weak evaluation can make the agent worse. So learning needs data hygiene, evaluation, rollback, and guardrails. For most products, start with stored strategies and feedback logs before jumping into fine-tuning or reinforcement learning. Example: fix my API login bug. Think: I need to debug login failure. Act: inspect authentication code. Observe: JWT token is not being saved correctly in local storage. Feedback: user reports previous fix attempt did not work. Learn: Previous approach missed token persistence step in client-side logic. Think. I should update both back-end response and front-end storage handling. Act. Apply, fix, and update client logic. Observe. Login now works correctly. Update memory/strategy. Always ensure JWT is stored after successful login response. Check both back-end response and front-end persistence. Final result. Login bug fixed with improved token handling strategy learned for future cases. Conclusion. The main idea is simple. You do not need every agent pattern at once. Start with basic React. Think to act, to observe to result. Then add only what the product actually needs. Add conversation when the user must clarify. Add description when transparency matters. Add multi-action when independent tools can run in parallel. Add reflection when quality needs retries. Add memory when context must persist. Add planning when the task is long. Add stronger reasoning when the task is hard. Add learning only when you have feedback, evaluation, and rollback. Agent design is mostly about trade-offs: speed versus quality, automation versus user control, memory versus stale context, planning versus flexibility, learning versus safety. If this helped, like and subscribe. It pushes the lessons to people who actually care about the topic, and you'll catch the next videos in this series. It costs you nothing, but it means a lot to me and my team. If something clicked or you have a question, leave a comment with your use case. I read comments, and they steer what I publish next. To learn more about me, visit this page. For agents, RAG, MCP, and related pages, visit this page. Same links are below in the description and pinned comment. Huge thanks. Your attention makes the work worth it for me and everyone behind the channel.